session. So you can hear it as we go back over it, and it should be up by Friday. This session should be there by Friday. You can't hear anything. Okay. One thing you can try and do is, Tiffany, if you're still there, just right click anywhere on your screen, and you should see settings, and then if you say settings, you click on allow. I think that might be the problem, why you can't hear anything. We are. Hi, Carlos. It's good to hear you. Good that you there. I'm actually going to take off the microphones now, and if you you can either just put it in the chat, or if you can just raise your hand and I will give you the microphone. Okay, so off. Anytime if you'd like to chat, just give that one up there or raise your hand, and then we can actually allow you to give feedback. Right, here we go into tonight. Back into the diploma, but we're also looking at it from the other ones, and the fridge magnets. Just remember, for those that are new, like Roz, if we look at the body of knowledge on which the diploma is, PMBOK body of knowledge, which the diploma is actually based on, there's 9 knowledge areas, which are the same competencies that you would see in the diploma, and there are 5 process groups or groups of processes, and there are 44 processes. Okay, and those 44 processes feed into the 9 knowledge areas. Okay, so that's what we're actually looking at if we look at those. And to see those 9 areas, we can go and see right here are the 5 process groups: initiating, arrow. So that'll be initiating, planning, executing, controlling, and closing are the 5 groups. All right. Now, when these would be processes that they are. So activity definition tonight will be a process: activity sequencing, activity resource estimation, duration estimation, schedule development, and schedule control are the processes we're going to look at tonight. This area over here, when it says time management, is really the knowledge area, if you like, the PMBOK knowledge area. So let me just quickly go back to those areas. I'm just doing a little bit so that those that are new tonight don't get lost. The diploma of management is made up of 9 knowledge areas of the PMBOK standard, and they are, if we look at the life cycle of a project, we have 5 phases in that one. It's the initiating a project, planning a project, executing and monitoring, and then, or executing and controlling, and then closing the project. Now, what we're specifically going to look at are the processes that actually help us define the project schedule, if you like. What is the project schedule? And then those processes that actually help us to control the schedule. So what we're going to be looking at tonight are those ones. And you'll notice again, so much of our work as a project manager is worked in the first 2 phases, initiating and planning the project. As you will see with this one, planning, it's all about planning. So at least 4 of these processes we're going to look at tonight are in the planning group, and then the other 2 are really in monitoring and control, or executing and control. So let's get on. It's nice to have sorry, it's nice to have to see the processes that we're actually got here. So if we have a look at what we've got tonight, the first one that we're going to look at is to define these activities. and we look at what the processor input is onto this one. What we're looking at is really the scope baseline. That came out of our project charter. In initiating the project, we got a scope baseline, and we did a work breakdown study, or breakdown structure. We're going to look at a little bit more at the breakdown structure again tonight, but not in detail because we've already seen how we break it down. It's also known as a decomposition. It's also known as a work breakdown study is known as a decomposition of the project, and the project scope is made up of that. Then the environmental factors and the processes and the assets or the knowledge management of your area is also included into this. So in this first phase, if you like, in the first process that we do in scheduling time and defining time, is to define those activities in more detail. Now, and from that we should have a list of activity attributes, a milestone list, and activity lists. And I asked earlier, let's see if anybody here can answer, what is the difference between an activity and a milestone? What is the one contributing factor? Let's try and get Tiffany in here again. Tiffany, are you there? I hope you can hear this time. Tiffany? I hope you can hear. All right, I think she's back. I hope she can hear. All right, so what can anybody tell me what the difference is between an activity? What's the attribute that's different between a milestone and an activity? You can hear. Oh, great to hear that you can hear. All right, good. Welcome then, Tiffany. We're on the first part of defining activities. And I asked a question, so I'm hoping somebody can actually tell me. An activity is a task, or a milestone is a completion of it. All right, yes, Roz, activities contribute to reaching a milestone. Both of those are good. We're on the right track. But I'm looking for one particular answer, so just keep coming. Let's just see if there's something that will be different. Okay, the difference between an activity. What's the one attribute? There's one attribute that's actually completely different from an activity to a milestone. Yes, Roz, I agree with that one. It is a critical junction to get to the next phase. All these things are great. A milestone has no, I think he's answered this one. It has no work or time relation. Absolutely right. There is no work in that one. There is no duration in a milestone. Right, so a point in time, if you like. There's no time relation at all. Milestones are those areas of what you've put up there, and I think that's great. But an activity has work associated and a duration to it. So there's no work involved in a milestone. It is a sign-off. It's a point that you're going to get a sign-off, and there is no work in it. Okay, so that's the difference. Now, if we look at remember our work breakdown structure, there were some attributes of this work breakdown structure that I want to just remind you of, because it actually plays a role in this first defining of your activities. And when you get into the detailed planning, it's still there. The first one is the shape of that one. So it's a decomposition. When we look at it, you see it looks like an organogram in my picture that's over here. You break it down into smaller and smaller pieces until you can actually get to discrete activities. Activities that are manageable. Right? So that's what you're trying to do, is to break down to that one. And then there's another issue that we talked about for quite a while, was a work breakdown structure dictionary. What we're really looking at with a work breakdown structure dictionary is to define what that activity is. All right, so in that one you will have a table that shows the precedences. A precedence is an activity that comes before another activity. Okay, so it's dependent. So an activity is dependent upon another activity. You would see it in your work breakdown structure dictionary. It also describes the type of resources that you're going to be using, the duration, what is expected, the deliverables attached to it, and all the resources attached to that activity. So it's critical even at the initiation stage and the initial planning stage is to get the work breakdown structure. So that's what we want it for. Okay, so the only other thing that I'd really want you to look at that are those ones. Because we've done work breakdown instructions before, I'm not going to spend too much time on it. And I just want to look at some of the one other aspect, and I haven't got a nice picture of this one, but I want to just look at what's important in this planning one is what they would call what you would call rolling wave planning. Can anybody give me what you expect rolling wave planning to be? Term that you're going to come across. So if you write the PMI exam, they're going to ask you what is a rolling wave. What is rolling wave planning? Not too worried. It's just terminology that you want to get, but there is a technique. What is rolling wave? Can anybody answer? Not quite, Anthony. No, it's not actually fast tracking. We'll talk about fast tracking in a minute, but it's not fast tracking. Rolling wave planning means that you're not going to plan in detail every phase of the project. What happens is that you'll come to a phase, and as you start getting into the next phase, you will start planning the activities on that one. That's because the phase is dependent on the other phase. So let's just say that you've got a phase of designing a piece of software. In that one, you're going to need a requirement study, and so you're not going to be able to plan in detail the programming until the requirements analysis is done. So you can, at this phase of the project, you will go and do a requirement study in detail, and you will just say, well, we have to finish the design of the program by this date and the implementation of the design by this date and the testing done by this date. But the actual detailed activities are dependent upon what the outcomes of the phase of the requirements analysis. So you only do the detailed planning after each phase. That's a rolling one. So if that makes sense, I can go on. That's the only other technique that I wanted to actually bring up in defining activities. Okay. Let me go on then to the next one. And that is activity sequencing. Now, activity sequencing is about how we put the various activities together. And when we do these activity sequencing, we often call them by a name called network diagrams. And there's two network diagrams, or actually three, that I want to actually talk about tonight. But before I do, let's just have a look at the process, what the inputs are. Very similar. We need all those activity lists again. We need the organizational knowledge base, if you like. We need the scope baseline again, and we need the activity attributes. And what we will come out with this process in the end is a project schedule or a set of network diagrams. Obviously, we'll update the project documentation. So we'll come out with a project schedule and network diagrams. So what is the worth of a network diagram? So that's what I want you to keep in mind when we look at these ones now. And let's have a look at the worth of these diagrams. Then you should see that what we should get out is that the worth of these diagrams is the ability to be able to replan or to plan with them. All right, let's have a look at the first one. This is old. You won't get too many of them, but there are a couple of questions they're going to ask you on it. And the first one that they're going to ask you on, I'm pretty sure that you're going to get a question. You would get a question like this: What is the network logic? What network logic diagram uses dummy tasks. Right, I think it might have, if you had the commencement test, you might have seen that one. What network diagramming method uses it? And this is the only one that uses it. Right? We call it a network logic diagram because what happens is the arrows actually represent the tasks. In this diagramming method, the arrows represent the tasks, whereas the node shows the dependencies. So if we look at the start, the starting of the project depends on activity A and D. The finish of the project is dependent upon C and F, and C is dependent upon B, and believe it or not, it is also dependent upon D. All right, so there's two dependencies. E is dependent upon D, and C is dependent upon D. Now that you have to have that dummy task because you have to demonstrate that relationship. There's two relationships that come out of D, that D is there. So it's not very popular, this, and you won't see too many diagrams like this one. The only reason why I've got it here is so that you can get an idea in case you pick up one of these diagrams in your project management at some stage. You'll at least know what it is. What is useful is precedence diagramming method, and most program software will use this one. Right, that's where the network diagram is drawn using a precedence diagram, and the nodes themselves are the activities or the tasks, and the arrows show the dependency between the tasks, or else between the nodes. Right? So most software uses this way, and most modern projects will certainly run this way. So what is important with this one are the relationships that we have between the nodes, and there are 4 relationships that we can actually have. 4 relationships that we'd have in diagramming and using this method. Right, and now I'm talking about diagrams. Just remember I asked you to remember the question, what is the purpose of this diagramming? How is it going to help us in determining project sequencing, and how does it help us as a technique in projects? All right, now the first one is the finish to start. Finish to start. So if you look on there are 2 activities that I've just put up on the screen, and as soon as the one task is finished or activity is finished, the other one can start. So the second task is dependent upon the first one. So if we have a look at the diagram above there, A is dependent on the start, and D is dependent on the start. C is dependent on the completion of D, and E is dependent upon the completion of D. So very similar to the other one, except that the nodes themselves are the tasks and the arrows show the dependency. That way we don't have to have dummy tasks. Now the second one we have is a finish to finish. Right, a finish to finish. Now this comes in normally because you have an external precedent where you cannot start the next lot of unless both the 2 tasks are finished. So the finish to finish, both tasks has to be finished at the same time. Now that's not very popular, but it is one that will be there, and normally there's an external constraint that forces you to have a finish to finish. The next one is to run activities in parallel. So your start to start means that you can actually run 2 activities together in parallel. Right? It'll run 2 in parallel. Now you'll save on time on this one, but you'll certainly use more resources because you cannot use the same resources on both activities. So if you've got the resources, then you can use a start to start. And then the final one that we're going to see, and is not very often used, is the start to finish. It's really a backwards one, isn't it? So you won't see too many of those ones. That means that if the start of A is dependent upon the finish of E, right? So what would be the importance? One of the important things about these diagrams is that they're going to get a construct in the end that will actually help us measure what and how this project, what is the complete duration of this, and what is the impact of each of these activities. That's what we want to get to. So the project sequencing using this network diagramming, in fact, we'll get to a thing called a critical path. And we're all building up to that critical path. We will see it when we do our last one, or activity duration estimation. What we really want to get to in networking is to find the critical path. Now the critical path, I'll tell you now so that I can remind you a bit later, the critical path is a set of activities that has no slack time or flow, what they might call float time. In other words, it is your highest risk or set of activities that form the highest risk of the project, because there's no time in between to do it. And that's where you're going to have to put in buffering, or you're going to have to do some sort of contingency planning is on your critical path to actually mitigate some of the risks that you're going to have in your estimating of your time resources. Same thing's going to happen with your budget as well. So, but before we get there, how do we estimate activities, resources? How do we estimate activity resources? I'm talking a lot tonight, so if you want to interject on anything, please do. All right? Now, to estimate on activity resources, it's again the process, and the techniques that we're going to use are these. And the first technique we're going to use is expert judgment. All right, so if we want to know how much resource we're going to use, then in your team, hopefully there'll be someone that has actually done this before. And not once, but has a lot of experience in doing these tasks that you're going to be doing here. So on your project team, you'd hopefully have an expert that will be able to say that this job is going to take so long. Why can I say that? Because I've done it before. I've done it many times, and I have records of this being done this time. So it's the expert judgment. A judgment of someone that has experience, a judgment of someone that has an expert and can actually help predict. Another way of getting evaluating and predicting resources that are required for activities are alternative analysis. Now, alternative analysis is important if we look at multiple activities and we have a look and see multiple ways of doing the same job. So an activity is a piece of work, and we can actually analyze it by looking at multiple ways of doing a job. We'll see which one would fit the project the best. The third one is published estimating data. Now, published estimating data would be data that you would pick up from often from an industry council, or an industry body. So if you had a construction industry body, they would probably publish things like how long it takes to build a particular building using this particular type of material. So they would publish the estimated results of particular buildings and square meterage. What I could think of is if we used tables, if I can remember in my estimating when I did planning project or planning for cable networks, we had a whole lot of tables that could tell us, depending on what we wanted to lay, how many cores that the cable had, how thick the cable was. We'd be able to tell how much labor we would need and how long it was going to take to lay a certain cable. Right, so, and we would calculate it per 100 meters, for example, or per meter. We'd have two tables, one per 100 meters and one per meter. So that is a way of publishing the data, and everybody knows and can use those estimates because it's been checked over and over again by various ones. So published estimating data would be one way to find the estimate the one way to find resources that you would need. I'm going to mention bottom-up estimating. I don't know why you would plan this way, but it means that you haven't done a work breakdown structure far enough to be able to estimate something. So when we talk about bottom-up, actually what we're talking about is saying we've come to an activity and we cannot estimate this activity. What we've got to do is look at this activity and break it down again into smaller components. And maybe we don't want to record those smaller components to actually get it. So we would call that one bottom up. So we'd break it down again into smaller components. And then we would estimate each of those components and only record in your project plan the sum of those ones. That's what they mean by bottom up estimating. And of course, there are software packages that will actually help us with estimating as well. Project management software and many other pieces of software can actually help us do some estimating by doing models for us and by doing many things for us. Okay, now let's have a look at duration estimation. Now, let me just go back for 1 second. Anthony's actually made a comment, and I think you've all read it, that he says a lot of small organizations do bottom-up estimating due to a lack of skill in the organization. Yep, that's quite possible. In fact, I agree with Anthony. Right? A lot of projects are small enough to be able to do that. If you can remember from Hartley, he says he gave you 3 different kinds of projects, and often on the smaller projects, it's quite you're going to use a lot of expert judgment, and you won't have to use some of the techniques that are actually there and available for us. Now let's look at defining those activities a bit better. Get out of sequence. Did I go backwards? I just made a mistake on the title. What we're actually going to be doing now is duration estimation. So please ignore my defining activities here. It's actually, we're going to look at duration. How do we calculate duration? Now normally we would say there's so many man hours to do this job. If there's so many man hours to do a particular job, then if you put 2 men on it, or two human beings on it, then it's going to be half the time. And if we put 3 human beings on the job, then we're going to have it in 1/3 of the time. But it doesn't often work like that, right? So what are the ways that we can actually do some duration? What we're going to come down to is program evaluation and review technique, PERT, right, which is really a weighted average. So and the reason why I've got it up here now, before I do any of the other ones, is because you're going to probably use PERT if you want to estimate your project and be able to take into consideration and mitigate some of the constraints and assumptions that you make in it. Because you're going to look, and I'll show you how we're going to do that. Right, so really the PERT is what the sum is of estimating duration. Now obviously you're going to have expert judgment again, and analogous estimating, which really says that if I've got a project that's done before, I can just use that project and change it. Now a good example of this one is a recipe. Let's say you have a recipe for 4 people and you want to do it for 16 people. Then it's you're going to increase the resources by four times, aren't you? So the things that go into making a particular recipe, say a cake, and you want it for 4 people, it's going to be a particular size. And if you want it for 16, it's it's the same recipe, except you're going to use quantities that are 4 times the amount. That's what we mean by. The other one is parametric estimating. Now, parametric estimating is doing something very similar. Let's say that we know that it takes let's say an hour to lay 25 meters of cable. So if we want to lay 1,000, or a kilometer of cable, it's going to be 1,000 divided by 20 by 25. And so how long is it going to take? That would be estimating a parametric. In other words, we've taken something that we know what it's going to, we know what the outcome for a small one is, and all we do is that we use that one to calculate the estimation. Next one, the 3-point estimating, which brings us back down to the PERT one. Now let's just try and analyze this one a little bit, because this is probably one of the best tools that or one of the tools that certainly help you in your estimating. It's a weighted average, and what you're first going to do is you're going to say, well, what's the most likely timing for this? And you're going to use the 3 other tools to actually get the most likely. Then you're going to look at it and you're going to say, well, these tools say it can be done here, but my expert judgment says that optimistically we can actually cut this down by 5 or 10%. So our optimistic one is going to be less, 5 or 10% less duration. Or someone could be pessimistic and say, well, we're going to get a lot of rainy days, so it's going to take us twice as long. Right? So the estimated time to do that is this calculation. All right, your TE is equal to your optimistic time plus 4 times your most likely, and then you're going to take your pessimistic time, and you're going to divide it by 6. Okay. Do you all see why divided by 6? All right. So if we did that for each task, we would be building in enough float time into each one of these tasks. So at the end of this one, we will be able to estimate fairly accurately what this task is, and we are building contingency time into each of these tasks. By using the optimistic and the pessimistic time, we are likely building it in there. So if we're going to build that time into the task, we must be careful when we come to the critical task to actually bloat those tasks. To bloat them means that you're going to put in more than what you estimated because you're scared that you haven't got enough time, or if something goes wrong, then the project manager is going to be held responsible because he didn't plan enough time to do something. I'm going to say to you now, that's not a good method of doing it. It's better to estimate accurately with that, and then put into your project assumptions that you need, that this is the critical path, and you need to put in contingency plan from your risk. Remember, we're going to do risk management, and we say your critical path becomes one of your biggest risks in project management. So instead of bloating each of the tasks and putting extra time into it, what you're going to do is you're going to build in contingency time. Okay. And that's called buffering. Now there's 2 ways you can do that buffering. You can take the sum of these tasks. Okay, so you can take that plus that and come out with a buffer at the end of it. Or you can buffer the tasks by putting time in between these tasks. Right, now that's a good way to do it, because if you're a good project manager, what you're going to try and do in your project, especially if it's a large one, what you'd want to try and do is, in fact, to complete your tasks as quickly as possible in the front. In other words, crash your tasks in the front so that you have enough buffering towards the end. And then you can actually reduce the time of your project. Right, so a good project manager will always be looking out for a better way. So you've estimated your project duration, but a good project manager will always be looking a way to improve the timings of that one right in the beginning of the project. Some of these methods to do that will obviously be looking at those ideas of crashing the thing, or we'll talk about the other two in a minute. All right, but before I get to those ones, what you want to also be able to do is to build in lead time and lag time. Can anybody tell me what a lead time is? What does lead time do? What does lead time do to a project? I've been talking a lot. Let's see if someone's still awake because I've been talking so much. Anybody tell me what a lead time is? What is a lead time going to do to, well, let me ask it this way. What is lead time going to do to the successor activity? All right, so if I have lead time in here, what is it going to actually do to task B? No answer tonight. It's going to delay task B. Exactly. Yes. Roz, it's going to accelerate. No, it won't. No, I don't think it's going to accelerate anything. But what it does do is it's going to delay the start of task B or the successor. Whereas a lag is going to accelerate it. So a lag time could accelerate the task B because you can actually bring the task B back in duration. Yes, Ross said accelerate. That's correct. Delay task B is what Dodie says, and I agree with that. Anthony says defines the latest delivery time without affecting the critical path. Yes, a lead time can do that. So an external lead time will do what Anthony's just done. So let's look at an external lead time. So let's say I need to order something and there's a 6-week lead time on that one. So one of my tasks would be is to order something 6 weeks before the successor task. So you order a piece of equipment 6 weeks before the successor task has to be implemented. So if I want to buy a server and I've got a 6-week lead time on it, then I need to order, or the precedent one would be, has to be at least 6 weeks in front of the successor. So that's what he's actually saying when Anthony says that it defines the latest delivery time without affecting the critical path. So you should have planned for something if it's going to take so long. Now the nice thing about that one is you might be able to squash that one in. Let's say that the lead time is 6 weeks and the supplier says you've got to put in 6 weeks, but he actually delivers it in 4 weeks. Well, that's going to help your project, isn't it? And it will affect your critical path, but in a good way perhaps. All right, let's have a look at now 2 other things that I want to just talk about before we go on. And that is, if you are planning your project, no, I can do that one a little bit later, so we can go on now. All right, let's look at, we've looked at duration estimation. Now we need to look at schedule development. Right, schedule development. There's a couple of techniques that we can look at in schedule development, but before we do, let's just look at that process quickly. All right, it's going to take your baseline and your resource calendars and all of that into it. But what do we want to get out of this one? what we want to get out of here, it will be your scheduled project time. All right, your project schedule will come out of this. When you have finished with this one, you will have a project schedule. You will be ready to start implementing, and you should have an accurate schedule. All right, so that's what comes out of this one, this process. So what are the tools and techniques we're going to use? We're actually going to define the critical path. So when we develop this one, we will have a critical path. So when we've looked at the network and we've analyzed it, we should come out with a critical path. All right? We're going to talk about a chain just now. I just what the chain method is. It's the same as the critical path, but it has a unique structure to it. But I'll talk about that in a minute. We're going to look at resource leveling. One of the things that we would do is build a what if scenario, so we can actually put some variables in there and see what the effect on the network the variables would have. So we're going to look at some of the constraints and assumptions, and a scenario analysis will take those assumptions and those variables, and you will actually put those variables and assumptions into the network path or into the network diagram, and you will actually try and understand what the impact of those assumptions are going to be. Same with constraints. Constraint is something that is going to be, weather could be a constraint, lead ordering time or lead times on ordering would be a constraint. Those type of, or a contractor can only start at a certain time, or your resources will only come at a certain time. Those are external constraints to your project, and what you're going to do with your what if scenario is say, well, what is the impact if some of these risks come about, or what happens if this is delayed? What would it affect on there? Now, very often, if it's not on the critical path, you have a lot of float time or bloat time, if you like. It's not on the critical path. That's why a project manager really, really needs to try and understand and get to the critical path, because the critical path is that path from the start to the end of the project that has no time extra in it if something goes wrong. So it's on that path that you really need to concentrate your risk analysis. Okay, if that makes sense. Now, what you can do on the critical path, there are a couple of things that you can actually do. That's besides those ones. Let's get to it. Sorry. It's what you would like to do is to build in and do a reserve analysis. Right? So what you remember I said to you that it's important that on the critical path that you don't change or bloat the tasks that are on there, because what will happen is people will fill that time and you will gain no advantage of it. What is better to do is to say, well, this task actually takes this time, and then for contingency wise, what you're going to do is you're going to do a reserve analysis. How much time must I actually put in outside of those ones for as a reserve? So if something goes wrong, I've built in a reserve time, but you don't schedule that into the activity. You keep it as something separate. All right. So reserves are often known as buffers, and sometimes you put it right at the end, but it's probably better to put it right throughout the project. Okay, and that's a fixed number of work periods that you want, but don't put it into your estimated activity time. Now, let's see if I can do something here. Let's look at schedule compression. Schedule compression. What do we mean by schedule compression? Anybody tell me what we mean by schedule compression? Okay. We need to shorten the critical path. That's right. Schedule compression is to look at how we can actually shorten that path. All right, so there's two ways that we can do it. One way is called crashing, and the other way is called fast tracking. What does crashing do? Crashing is a technique in which there is a cost schedule trade-off. Okay, so an example of an example of crashing would be approving overtime, putting additional work resources onto something, paying for more things. That would be crashing. So what we'd actually do is that you put more resources onto an activity to reduce the time of that. Now, that's one way to do schedule crash. So that what you would do is if you wanted to crash the time. Now, the reason why I'm telling you now, you would see that this will come back again when we're looking at controlling the project. Right, so it's better to do your normal one, and then if you have to crash it, then you can crash it and put more resources on there. The other one is called fast tracking. Now, what fast tracking does is it often increases the risk, because what you're doing is you start putting things in parallel. What you're doing with fast tracking is you're looking at the network, you analyze the network and you see how many of these tasks you can actually put in parallel. All right. So the risk is if it increases the risk, and often makes the problem of rework, and causes a problem of rework. That's actually the risk that you're actually taking. So fast tracking only works if the activities can be overlapped or shortened. Okay, so that's what we mean by fast tracking. Now, for schedule compression. Now, let's try and understand this one. If we're given the following diagram, all right, so we have a duration of 4 days, 4 days, 5 days, 6 days, and 2 days, right? And the precedence is A. So B can't start before A, C can't start before A, B can't start before, sorry, the other way around. D can't start before B is completed, and E can't start before that. All right, so that's a table that's actually given to us. All right, so if we look at it to install a shed, what we would see is that this would be the critical path, wouldn't it? Let me show you the critical path. You would start here, it's 3 days here, and there's 1 day there, and the whole task takes 6 days. Right, you'll now see that there is, on the other path, you will see that there is actually a whole day that you've got extra to play with. Right, so connecting the utilities could come a day late if you wanted it. Right, so that's your network analysis for building this shed. So now let's have a look at your diagram. You see that here you have an estimated start of day 1, and then you have an estimated finish of day 2. So if you take this path, you're going to come out with 5 days. And if you take the other path, you're going to come out with 6 days. Right? But you're dependent upon the 3-day critical path, because that's how long it is going to. You can't do it before that, because it takes 3 days to clean up the site. Okay? Now, let's add let's look at the lag. Okay, so there is a lag on that one, right? That is the lag time that you would see on those ones. So we have a whole day's lag on that one. If we wanted to compress it, we could bring it down to 5 days by adding or crashing it on the cleanup, by putting more people on the cleanup. That would be crashing it or compression. And then we could bring it down to 1 day, and you see that what we would do then is we would change the critical path to the top one. If we had to crash and put more resources on the cleanup site than on the utility site would then become the critical path. Now, there's the critical path with the two little things on it. The final one in designing your schedule or scheduling designing your schedule or developing your schedule is the Gantt chart. Using project management software, it's going to do it at the same time. So as you link your precedents together, it's going to do and develop your Gantt chart for you. Now, if you have a look on Saturday and Sunday, what a Gantt chart will actually show you is that the task has to go through that one. So there's 2 days on that one where your task goes through the weekend. So these are all finish to starts. All right, so you can't start that one task B before task A is completed, and the same with the next task. Okay. That would be an example of a Gantt chart. Now your Gantt chart is a useful tool because on your Gantt chart is where you can fill in what is being completed and what hasn't been completed. If you need to do compression or you need to do fast tracking, it's going to actually show up on your Gantt chart first. Then you can go to your network analysis to find out how best to do this. So you're going to constantly be using the Gantt chart as a tool, and you're constantly going to be using your network diagram as a planning. So your network diagrams are more planning tools, whereas your Gantt chart is going to actually help you to understand where you are on the project, because that's what, as the tasks get completed, you can see how much time is available. Okay. Let's have a look at network control. What are the things that you're going to look at in controlling your schedule? So you've got your whole project plan, you've got your resource schedule, which we talked about in there, and you've got performance measurements. That's what you want to get out of here, are those performance measurements and your schedule data and your update to your project. So that's what you get out of controlling it. Now, we talked about that, some of those things on that one. So the question I would have to ask you now, what are those techniques that we're going to be using? And you'll see that they are exactly the same techniques that you've actually used with 2 added. All right? 2 added. You can adjust your lead and your layout times. You can do schedule compression. You can still do resource leveling. You're going to use your project management software. And then there's 2 more here. Performance reviews and variance analysis. A variance analysis is very important when you get a baseline. And that's why baselining is so important. So once you've done your project schedule, you get a baseline. Your baseline is going to help you if you're starting to get a variance. So if there's a variance between what you've budgeted in time and the actual time it's taken, you can see that start looking for the areas that will be critical. So if it gets to a critical area, you can actually look at seeing if you can't adjust some lead and lag times, or you can do some schedule compression. So if your variance becomes too critical and you can see that it's going to change your critical path, or that it's going to exceed what you've planned or have contingencies for in that critical path, then you can see if you can actually do some compression or some what if scenarios or some resource leveling or something to actually bring down if your variance. So your variance analysis is a tool to actually help you control the project. Now, and the same with your performance reviews. All right, I have got a few minutes left. Are there any questions for tonight? In time, project time. Any questions for tonight? Anthony, yes, I'm terribly sorry. It should have gone up today, but unfortunately, it didn't get up today. And the quickest I can have it up now is because I'll be away for this week is on Friday. So I'm very sorry, but the assessment is only going to be up on Friday. Sorry about that. Um, Lance, the first assessment is actually your project integration, but I suggest that you don't do your project integration until last, because each one of these knowledge areas is going to assist you in developing the project integration ones. There is already one up with your scope. Your scope assessment is already up, so you can actually start on that one. So Lance, your first assessment could probably be your scope, developing a project scope, and that you can actually do right now. No, there isn't. You can do it in any time that you want to, Lance. Um, you can submit. There's no there's no schedule for it, and in fact, um, there's no what you're going to see with these assessments, because it is competency based. What all we want to do in assessing it is that you provide us with enough evidence to show that you are competent to do each of these areas that, or each of these units. And they're broken down into various areas. Um, if you have a look at the training plan, there are certain performance criteria that you should be able to perform. There's an underlying knowledge and an underlying skill. And what we're going to be looking for is, do you have the underlying knowledge for each of these units? And do you have the skill in each of these units? And can you perform the tasks to a competent level? So we're looking at, when we say performance criteria, we're looking at something that actually shows us that you are competent in a particular area. So if you look at each one of those units, it actually has the training package there. And what we want to disprove is that you are competent in each one of those areas. That means that you can do it in any order that you want to. We do have to have, um, depending on who the funder is, there is a contract um, that we probably would have to fulfill. So if you're doing it in New South Wales, you could in fact take up to 2 years to do it. Um, but some of the other contracts are a little bit smaller, less time. In other words, I think the one in Queensland is only a year, and the one in Western Australia is a year. So they really want us to be finished within somewhere around within a year. However, um, that's up to you. There are some cost implications if you go over. That's really what the issue is there. Really, you can take it as when you can. I'm trying to get all Anthony. I'm trying to get up all those assessments up. The RPL is already up. So yes, the RPL is already up. I'm only going to be able to get the assessments up as I do each of the sessions on here. Get Sorry, Roz, I wasn't sure. That would be really beneficial to get through info prior to the sessions. I can give you quite a few of those. The RPL Lance doesn't have any time frame either. Roz, I'm not too sure of your question. If you could just rephrase that one for me. Um, I'm not too sure of. Are you saying the other? What is up there at the moment? No, I'm probably not going to be able to get up everything, having the assessments up prior, so we can ask per. The questions are on the question bank. So if you want to look at the questions that we're going to be answering or asking, you can actually look at the questions on the question banks of the RPL, and that will actually help you with the with answering the questions beforehand. It'll also help you with asking questions here if you don't understand something. So although you don't have to do the RPL, I really suggest that you look at the questions in the RPL question banks. That will really help you get an understanding of what is required for these ones. So those questions on the RPL will help you an enormous amount. I would suggest that that's what you would do there. Any more questions? Then I'm going to thank you for attending again this evening. Thank you very much indeed. All the best for doing these, and good night.